Consider the diagram below in which BD is the angle bisector of ABC, angle bisector. So see how they marked that they were congruent? That's because it's the angle bisector. And also AE is perpendicular to BD. So that's why they marked this as a 90-degree angle. Write a proof for each statement. ABF is congruent to EBF. Well, that's very clear because already we have angle, and we have a side that with a scale factor of 1. So write a proof for this. We know that BD bisects angle ABC. That's given. And because we know that angle ABF is congruent to angle FBE. That's based on the definition of bisector, right? Definition of angle bisector. If it cuts the angle in half, it creates two congruent angles. So right there we've got this angle. We're given again that AE is perpendicular to BD. That's given. So that means that angle AFB is congruent to angle EFB, right? Both are 90-degree angles. And then we know that segment BF is congruent to itself, right? Segments are congruent to themselves, right? So that's enough to prove the two triangles are congruent because triangle AFB is congruent to triangle EFB by side, angle, side, right? No, that's not right. By angle, angle, and scale factor of 1, right? So that's A, that's the first part of A. Now they want us to go forward. So first part of A, this is AI stopping there, and they want us to prove that triangle ABE is isosceles. To be isosceles, it just means that two of the sides are congruent. Well, right now we then know, because these are congruent triangles, these two are congruent triangles, we now know that AB has to be congruent to BE. AB is congruent to BE, and this is again because of the corresponding parts of congruent triangles are congruent, right? So I'm shortening that. The corresponding parts of congruent triangles are congruent. And if AB is congruent to BE, then that means that triangle ABE is isosceles by the definition of isosceles. Any triangle with two sides that are the same are isosceles. Now for B, on a copy of the diagram, draw a line perpendicular to BD through point C and intersecting AB. Okay, so let's think through that one more time. It has to be perpendicular to BD through point C and intersecting AB. So kind of straight across here, right? So trying to draw that straight edge. Okay, so notice it's going to be parallel to this line right here, right? So if we draw that perpendicular, so it intersected AB, it was perpendicular to BD, and it went through point C, right? So now identify all pairs of congruent and similar triangles. So ABF is congruent to EBF. We already proved that. But by the same proof, we'll be able to prove that this, right? And let's label these points something new. Let's label this G and this H. So now HBG is going to be congruent to CBG by the same proof. So that's another one right there. That's one of the triangles. So like triangle BHG is going to be congruent to triangle CBG, and that's going to be by the angle, right? So same kind of proof right there. Now they're wanting us to also identify some similar triangles. So here's the thing is that like these two are congruent, but this triangle is actually going to be similar to these two smaller triangles because look, they still have angle, angle, right? So triangle BHG is going to be similar to triangle BAF by angle, angle. And that also then means that BHG is going to be similar to EBF. And it also means that because those two are congruent, and also means that these two smaller triangles are going to be similar to CBD because this is congruent to that one. So there's a lot of similar triangles as well in here. You just, by drawing that parallel line, you created some similar triangles in there. So there's more to list. So you finished listing all pairs of congruent and similar triangles. We've listed the two. This one is the new congruent, and then finished listing the similar ones.